Welcome to VP's Math Solution. It is your Premlata Vasudevan here. In this part 2 Fourier series video, we are going to see half range sine and cosine series, complex form of the Fourier series as well as harmonic analysis children. What is half range series? At times, it is required to expand f of x in the range 0 to L in a Fourier series of period 2L. So for it, what we'll do is we'll arbitrarily extend the function in the interval minus L to 0, right? If we extend f of x by reflecting it in the y-axis, like f of x and f of minus x are equal, it is even, we get Bn to be 0. So the Fourier expansion contains only cosine terms. We call it as half-range cosine series. If we extend f of x by reflecting it in the origin, that is f of minus x is equal to minus f of x. It will be odd. So a naught an will be 0. The expansion contains only sine term. It is said to be half range sine series. Now, half range sine series in 0 comma L is f of x equal to summation n equal to 1 to infinity bn sin n pi x by L, where your bn is 2 by L integral 0 to L f of x sin n pi x by L into dx. Suppose you want the same half range sine series in the interval 0 comma pi, L will be equal to pi. So wherever it is L, replace it by pi, you will get the half range sine series. Now, half range cosine series of f of x in the interval 0 comma L is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by L, where a naught is 2 by L integral 0 to L f of x dx, and a n is 2 by L into integral 0 to L f of x cos n pi x by L into dx. Same, if you want to have the half range cosine series in the interval 0 comma pi, your L is pi. Wherever it is L, replace it by pi, you will be getting the half range cosine series in the interval 0 comma pi. Right? Parsifal's identity. If the half range cosine series for f of x in the interval 0 comma L is this, then your Parsifal's identity is 2 by L integral 0 to L f of x the whole square into dx is equal to a naught square by 2 plus summation n equal to 1 to infinity a n square. And then if the half range sine series for f of x in the interval 0 comma L is f of x equal to summation n equal to 1 to infinity bn sin n pi x by L, then your Parsifal's identity will be 2 by L integral 0 to L f of x the whole square into dx, which is equal to summation n equal to 1 to infinity bn square. Now we are going to see the first problem. Obtain the half range sine series for f of x in the interval 0 comma L. Hence deduce summation n equal to 1 to infinity 1 by n square they are asking. Now what is half range sine series for f of x in the interval 0 comma L? First we have to write that. Write the formula for f of x. Mark it as 1. Then where bn is, write the formula 2 by L integral 0 to L f of x sin n pi x by L into dx. What is your f of x is? It is x. Substitute here. Now we are going to integrate this by Bernoulli's integration by parts. X power is 1. So you are going to have two pairs of bracket u v1 minus u dash v2 with alternative plus or minus sign. So you are just writing as such. Differentiate it. 1 you put here in place of u dash. Integrate this to put v1 here. Sin n pi x by L integration is minus cos n pi x by L divided by n pi by L. Now integrate this to put v2 here. Cos integration is sin n pi x by L divided by n pi by L. Already a minus 1 divided by n pi by L is there. It will be attached to it. So that it will become minus sin n pi x by L divided by n pi by L the whole square. Right? You are going to apply upper limit as well as lower limit. When you are doing so, you apply L here. LL will be getting cancelled. Sin n pi is 0. Apply lower limit. Sin 0 is also 0. So your second term is 0. Now, in the first term, take this L by n pi outside, right? So 2 by L into L by n pi plus into minus, it is minus x cos n pi x by L. You have to apply the limit. Upper limit L you have to apply minus lower limit. 0 into anything is 0. Wherever it is x, you are going to apply upper limit minus wherever you have x, you are going to apply the lower limit. You are getting the term like this. Cos n pi is minus 1 whole power n. Your bn is this. You are going to substitute the bn in equation 1. you're getting the required half range sine series for the given function f of x in 0 comma l, right? They ask you to deduce summation n equal to 1 to infinity 1 by n square, children. Here you have only 1 by n. If you want to have the square in the deduction part, you have to go for partials, right? As already we saw in our Fourier series, right? Full range series. Now to write the Parseval's identity, 2 by L integral 0 to L f of x the whole square dx equal to summation n equal to 1 to infinity bn square. Square bn and write here, right? Substitute f of x and square it. You'll be getting x square here. Now minus 1 whole power 2n. Minus 1 whole power any, what to say, even number is plus 1. So you are taking the summation to the left hand side, right? Other than 1 by n square, take all the constant outside. Here, this integral you are going to integrate on the right side, x cubed by 3, apply the limit. Then, other than this summation 1 by n square, take all the terms to the right side. You will be getting pi square by 6, children. Right, now we are going to see the second question. Find the half range cosine series for the function f of x equal to x into pi minus x in the interval 0 to pi. Deduce summation n equal to 1 to infinity 1 by n power 4. Right. So half range cosine series for f of x in the interval 0 comma pi is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. Right. Then mark this equation 1. Find a naught and a n, substitute here. A naught is 2 by pi integral 0 to pi f of x dx. You are substituting your f of x here, multiply x inside, then integrate, substitute upper limit minus lower limit. You will get your a naught to be pi square by 3, children. Then a n is 2 by pi integral 0 to pi f of x cos nx dx. Substitute f of x to be pi x minus x square. Then integrate this, right? uv, like Bernoulli's integration by parts method, we are going to integrate it. So you have power 2, degree 2 it is. So you will be having 3 pairs of bracket with alternative plus or minus sign. First, you are going to write in the first bracket, first term, pi x minus x square. Differentiate it. U dash you are going to write here, pi minus 2x. Again differentiate it. U double dash you are going to write it here as minus 2. Then v1 you are going to write here, integrate cos nx, it is sin nx by n. Integrate sin nx, it is minus cos nx by n. Already one n is there in the denominator, it will be n square then. Then integrate this cos nx, it is sin nx by n. Already minus 1 by n square is there, so minus divided by 1 by n cube it will become, right? So now you are going to apply the upper limit minus lower limit. When you apply upper limit, sin n pi is 0, sin 0 is also 0. So first term and third term are going to be 0. In the second term, minus of minus, it will become plus. In this only, you are going to apply the limit. After applying upper limit minus the lower limit, you are getting the terms like this. When n is even, what will happen, ma? This will become plus 1. 1 plus 1 is 2. So it is minus 4 by n square it will become. When n is odd, this will become minus 1. 1 minus 1, it will be 0. So you are writing it. Substituting a naught n value in 1, you get the required half range cosine series, children. Deduction part, they are asking for 1 by n power 4, but here it is 1 by n square. If the square is asked, you have to go for Parseval's identity. So write the Parseval's identity, 2 by pi integral 0 to pi f of x the whole square dx equal to a naught square by 2 plus summation n equal to 1 to infinity a n square. Substitute a naught a n, square it, then substitute f of x, square it, children. Now take the summation to the left side, simplify it. Similarly, the right side, inside the integral, it is of the form a minus b the whole square. So a square minus 2ab plus b square you are writing. Then you are integrating it. X square integration is x cube by 3. Then x cube is x power 4 by 4. X power 5 is x power 4 integration is x power 5 by 5. Applying upper limit minus lower limit, you are getting this value. Then other than this term, right? Here it is defined only for even numbers, isn't it? When it is defined only for even numbers, right? What you are going to do is you are going to write it as summation n equal to 1 to infinity. So that n will be replaced by 2n. See, now apply n equal to 1. What will happen, children? It will be 2 power 4. Here also, if you apply 2, 2 power 4. Then if you apply 4, 4 power 4. Here you apply 2, it will be 2 into 2, 4 power 4. Likewise, both are same only, equivalent. So you are writing this. Then this 2 power 4 into n power 4 is written separately. So 16, 16 will be getting cancelled. Other than summation n equal to 1 to infinity 1 by n power 4, you are taking all the terms to the other side, right? And even this pi by 2, you will be cross multiplying finally as 2 by pi to the other side. You will be getting the required result, children. Third question. Obtain the half range sine series for the function f of x equal to x in 0 to L by 2, L minus x in the interval L by 2 to L. So you are going to write the half range sine series in the interval 0 to L. It is f of x equal to summation n equal to 1 to infinity bn sine n pi x by L, children. What is your bn is? 2 by L integral 0 to L f of x sin n pi x by L into dx. It is a splitted function, isn't it? In the interval, it is given. See, in the splitted interval, they have given the function. So what you have to do is 0 to L by 2, you have to apply x. L by 2 to L, you have to apply L minus x. So 0 to L is splitted as 0 to L by 2, L by 2 to L. Then here it is sub x. Here we have to substitute L minus x. Again, by Bernoulli's integration by parts, we are going to integrate both the integrals. It is x power 1. So 2 pairs of bracket with alternative plus or minus. Then similarly here also x power 1 term. So same 2 pairs of bracket with alternative plus or minus, children. First u dash. U is x, u dash is 1. Integrate sine n pi x by L. It is minus cos n pi x by L divided by n pi by L. Integrate this. You will be getting minus sine n pi x by L divided by n pi by L the whole square. Similarly, same thing. L minus x is u and u dash is minus 1. How we integrate sine here? Similarly, here you are integrating and substituting. Now we have to apply for both the things upper limit minus lower limit. So if you apply 0 here, children, 0 into anything is 0, right? So sine 0 is 0. Lower limit is 0 for the first one. And then for the second one, if you apply L, L minus L is 0 and sine n pi. If you apply L, sine n pi is 0. So only here the upper limit exists. So L minus, this term is minus into plus, minus L by 2 cos n pi by 2. If you apply L by 2, LL will be getting cancelled. Cos n pi by 2 by n pi by L. Minus of minus, it is plus sine n pi by 2 divided by n pi by L the whole square. Lower limit is 0 as already we discussed. Then here you are going to apply upper limit, it is 0, and you are going to apply the lower limit. Both the terms are negative. This is a negative term as well as this is negative term. So both will be positive while you apply the lower limit. L minus L by 2. If you apply L by 2 here, it will be cos n pi by 2 by n pi by L plus sin n pi by 2 divided by n pi by L the whole square. Now take this n pi by L here as L by n pi, right? And then this will be L square by n square pi square into sine n pi by 2. Here L minus L by 2 will be L by 2 into, take this as L by n pi into cos n pi by 2. This will be plus L square by n square pi square into sine n pi by 2. These two terms will be getting cancelled because they differ only by the negative sign. These two are the same term, positive term. So add as twice L square by n square pi square into sine n pi by 2. To simplify, you will get the bn here. Substitute in the first equation, right? So you'll get the half range sine series for the given function, children. Then what you have to do is, you people have to, right, do the fourth problem. Here Fourier cosine series for f of x equal to x in the interval 0 comma pi, show that this is nothing but 1 plus 1 by 3 power 4 plus 1 by 5 power 4. This is odd numbers. Here it will be, see, so equal to pi power 4 by 96. We have to reduce this. So half range cosine series for f of x in 0 comma pi is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n x. Mark it as equation 1. Find a naught. A naught is 2 by pi integral 0 to pi f of x dx. Substitute x for f of x. Integrate it. A naught is pi. Your n is integral 2 by pi into integral 0 to pi f of x cos nx dx. Substitute x. This is uv format. Bernoulli's integration by part. 2 pairs of bracket with alternative plus or minus. U dash is 1 if you differentiate x. Integrate this. It is sin nx by n. Again integrate this. It is minus cos nx by n square. So apply upper limit minus lower limit. If you apply upper limit, sin n pi is 0. Lower limit, sin 0 is 0. So first term is 0. you apply limit for the second term. It is coming to be like this. When n is even, 1 minus 1 is 0. When n is odd, minus 1 is minus 2. So 2 into minus 2, it is 4 by pi n square. Substitute a naught a n value in the given, what is the equation 1. So you will be getting the required half range cosine series for the given function x, right, in the interval 0 comma pi. Now we have to go for the deduction part. It is n power 4. So go for Parseval's identity. Write the Parseval's identity. 2 by pi 0 to pi integral f of x the whole square dx equal to a naught square by 2 plus summation n equal to 1 to infinity a n square, children. Now while you are applying, this is defined, Pn is defined only for odd function. So you are writing here n equal to 1, 3, 5, so on till infinity. That is n is odd. So you are squaring it, right? And then a naught square by 2, you are writing it equal to 2 by pi 0 to pi, f of x is x. So x square, that is f of x the whole square, it will become x square dx. Integrate this. Then here, what we are going to do is, take this 16 by pi square. If you square it, it will be 16 by pi square n power 4. All the constant terms, 16 by pi square outside, 1 by n power 4 will be inside. Keep this term alone. Take this pi square by 2 to the other side. Simplify it, right? Finally, take the 16 by pi square to the right side. You will get the, already we have come across this in video 1, right? Part 1, Fourier series. If it is odd, we can write n equal to 1 to infinity and then replace n by 2n minus 1. Wherever n is, you can replace it by 2n minus 1. Right? Both are equivalent. You are writing it. So this is equal to pi power 4 by 96. It is a required result, children. Fifth question, ma. Obtain the half range cosine series expansion of f of x equal to x minus 1 the whole square in the interval 0 to 1. Hence, deduce this part they are asking. Summation n equal to 1 to infinity 1 by n square you have to find out. As usual, in 0 to 1, your L is 1 here, right? Your L is 1. So your half range cosine series will be f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x divided by L. L is 1. So it will be cos n pi x. Now a naught you are going to find. A naught is 2 by L. 2 by 1. 0 to L. 0 to 1 f of x dx. Substitute your f of x. Now you know this formula. Integral formula. Integral ax plus b whole power n into dx will be ax plus b whole power n plus 1 divided by n plus 1 into a plus integration constant c, right? Here your n is 2, your a is 1. You are integrating using this formula, you are getting this. You are applying the upper limit, it is 0 minus lower limit. Your a naught is 2 by 3 and you are going for your an. Again 2 by L. L is 1 here, 2 by 1, 0 to L. Your L is 1 here, 0 to 1. F of x cos n pi x by L. L is 1, so cos n pi x dx. And then you are substituting your f of x value. You will be getting degree 2 here, right? The function will be, so you will be having 3 pairs of bracket with alternative plus, minus, plus, so on, right? So write u here, x minus 1 the whole square, u dash here. Differentiate x minus 1 the whole square, it is 2 into x minus 1 into 1. And then differentiate this, it will be just 2. And then integrate v, you will be getting v1 and writing here cos n pi x integration is sin n pi x by n pi. Again integrate v1 to write v2. Sin n pi x integration is minus cos n pi x divided by n pi. Already 1 pi n pi is there. So the denominator will become n square pi square here. Again integrate this to write this term. So my cos n pi x integration is plus sin n pi x by n pi. So already a minus 1 by n square pi square is there. Here minus 1 by n cube pi cube will come along with sin n pi x. You're going to apply the upper limit as well as lower limit. Upper limit is 1. If you apply 1 here, sin n pi is 0. Apply the lower limit, sin 0 is 0. So first term and third term is coming to be 0. Apply the limit in the second term. You'll be getting your an to be like this. You just substitute this in the equation 1 to get the required half range cosine series, children. Then the deduction part is just 1 by n square itself. See, 1 by n square itself. Here your an also you have 1 by n square. So you have to go for convergence condition, not possibles. Children, you have to think summation 1 by n square should come means what this value will be. This should be 1. If this should be 1, the interval is 0 to 1. What will be the x value? You have to think and choose it. So here the x value, you can take it as x equal to 0, which is the end point. So uh, at x equal to 0, this will become 1. Cos 0 is 1. So you will be getting the required summation n equal to 1 to infinity 1 by n square. So you are taking the n point x equal to 0 here. So the sum of the, what to say, cosine series when x equal to 0 will become 1. You are substituting here when x is 0. Substitute 0 on the right side. Left side is 1. Right? Simplify it. Just keep summation 1 by n square as n tending to 1 to infinity alone on the left side. Other than that, you take it to the right side. You will get the required result. Last question in this half range series. We are going to find half range sine series for x into cos x in the interval 0 comma pi. So half range sine series of x, that is f of x in 0 comma pi is f of x equal to summation n equal to 1 to infinity bn sin nx, children, where bn is 2 by pi integral 0 to pi f of x sin nx dx. Now substitute f of x as x cos x. You do one thing, club cos x sin x together. Take this 2 inside, right? First I'm writing 2 sin nx into cos x. You will be applying this formula here. 2 sin a cos b is sin of a plus b plus sin of a minus b. A is nx, b is x. So nx plus x. Take x outside, it will be n plus 1 into x. A minus b is nx minus x. Take x outside, it will be n minus 1 into x. Now you can take this as u, this as v, and then you can integrate. Otherwise, you take you can, what is it, split the integral into 2, and then also you can integrate. I'm splitting here. I'm taking this sin n plus 1 into x into x. I'm integrating again. Sin n minus 1 into x into x. We were integrating. Applying Bernoulli's integration by parts for both the integrals. What it will be, my x. So 2 pairs of bracket with alternative plus or minus. Similarly, here also x. You are writing this. So x, differentiate x, u dash is 1. Integrate this minus cos n plus 1 into x divided by n plus 1. Cos integration is plus sin n plus 1 into x divided by n plus 1. Already minus 1 by n plus 1 is there. So minus 1 by n plus 1, the whole square it will become. Here also the same. Instead of n plus 1, it is n minus 1 into x. So if you integrate, that is, if you put x, u here, it will be x. U dash, it is 1. If you integrate, minus cos n minus 1 into x by n minus 1. Again, if you integrate it, it will be minus sin n minus 1 into x divided by n minus 1 the whole square. Now, if you apply upper limit pi, sin n plus 1 into pi is also 0. Sin 0 is also 0. Here also, sin n minus 1 into pi is also 0. Sin 0 is also 0. The second term is coming to be 0 here. So what we are going to do is, you are going to apply limit for the first term. So upper limit minus lower limit. Similarly, upper limit minus lower limit you are applying. You are getting like this. What you can do is, in both the terms, these two terms were 0 for the lower limit. What you are doing is, you take this minus pi outside. So cos n plus 1 into pi is minus 1 whole power n plus 1 divided by n plus 1. Cos n minus 1 into pi is minus 1 whole power n minus 1 divided by n minus 1 it will be. Now you can split this minus 1 whole power n plus 1 as minus 1 into minus 1 whole power n. Similarly, this also minus 1 whole power n into minus 1 whole power minus 1. What is minus 1 whole power minus 1 is? It is minus 1 is, it is again minus 1 only. So you will be having negatives. The negative outside will be taken inside. Both will be positive term. Take minus 1 whole power n outside. It will be 1 by n plus 1 plus 1 by n minus 1, right? Take LCM, simplify, you'll be getting the term like this. But the denominator, if you put 1, it will be become infinity. Bn value will become infinity. What is what we come across it, Bn is not defined for n equal to 1. So what you have to do is, you have to find b1 separately. What is a b1 is? In this formula, substitute n equal to 1. b1 equal to 2 by pi integral 0 to pi f of x sin nx dx. See, just write that, then substitute f of x as x cos x. Take this 2 inside, club cos x sin x 2 inside. Your sin 2x is 2 sin x cos x. right? So sine 2x, again Bernoulli's integration by parts. X, differentiation of x is 1. V1 is minus cos 2x by 2. Again integrate this, it will be minus sine 2x by 4. Substitute upper limit minus lower limit. Sine 2 pi is also 0, sine 0 is also 0, second term is 0. Apply the limit for the first term, you will get b1 equal to minus half. So substitute b1 and bn not equal to 1 in 1. Split the function, that is summation itself as b1 sin x, that is put n equal to 1 separately, b1 sin x plus n equal to 2 to infinity bn sin nx. Apply b1 here, apply bn here. That is the required, what is a half range cosine series, sorry, half range sine series for x cos x, right, in the interval 0 comma pi, right? We are getting the sine series for x cos x in the interval 0 comma pi. Then we are going to get into complex form of the Fourier series. Complex or exponential form of the Fourier series is in the interval c comma c plus 2l is f of x equal to summation n equal to minus infinity to plus infinity cn e power plus I n pi x by l, where cn is 1 by 2l c to c plus 2l f of x e power minus I n pi x divided by L into dx. Children, as we saw in Fourier series, whatever the interval may be, accordingly this will change. If L is pi, it will be, you have to put everywhere pi. Likewise, it will go on, right? Now, we are going to come across the problems now. Find the complex form of the Fourier series of f of x equal to e power minus x in the interval minus 1 to plus 1. So your L is 1 here. Wherever L, you substitute 1. So your complex form of the Fourier series is summation n equal to minus infinity to plus infinity cn e power I n pi x divided by 1. So that is, you are marking it as equation 1. Then you are writing cn value, right? Wherever L, you are putting it as 1, right? Then you are integrating. Before integration, put f of x equal to e power minus x. Now, e power a, e power b will be adding, isn't it? E power a into e power b. Similarly, this, the power will be added. E power minus x minus I n pi x. Take minus 1 outside. You will be getting like this. Integrate this. What is e power minus ax integration, ma? E power minus ax divided by minus a. So, in a is 1 plus I n pi. That's it. You are applying the upper limit. Wherever you have x, you will apply 1 first. Then wherever you have x, you will apply minus 1. When you apply minus 1, minus of minus, it is plus coming. Now again, e power minus 1 minus I n pi it is. Split this as e power minus 1 into e power minus I n pi. Here it will be e power 1 plus I n pi. So e into e power I n pi we are writing it as. You already know e power I theta is cos theta plus I sin theta. E power minus I theta is cos theta minus I sin theta. Instead of theta, you have n pi here. You are writing this, right? Your sin n pi is 0. Your cos n pi is minus 1 whole power n. You are substituting in the places of cos n pi and sin n pi. You'll be getting the result like this. Now the denominator is 1 plus I n pi. What you are going to do is multiply and divide by the conjugate 1 minus I n pi, right? And then take this negative inside. So what will happen, ma? It will become e minus e power minus 1. Then take this minus 1 whole power n outside. It will come as such. Take this 2 to the denominator, right? Here it is a plus b into a minus b in the denominator. It is a square minus b square. So 1 square minus I square n square pi square, it will be. I square is minus 1. Minus of minus, it will become plus, children. We all know the hyperbolic function sin hx is e power x minus e power minus x by 2. Put x equal to 1. So sin h1 will be equal to e power 1 minus e power minus 1 by 2. So this is sin h1. You found the Cn value. Just substitute Cn value in the equation 1. We get the required complex form of the Fourier series, right? Second one, find the complex form of the Fourier series of f of x equal to cos ax in the interval minus pi to plus pi. L is pi here. So you will be rewriting your, what is Emma? Complex form of the Fourier series f of x, where L is pi, right? You are writing it, marking it as equation 1. Then you are writing Cn, wherever it is L, you will be writing pi. Okay, substitute cos ax for f of x. Now you can do this integration in two ways. Either you can make this as real part of cos ax as what is the real part of e power iax. You can make it and then you can integrate, but not necessary. We can go for the standard integral formula. You all know integral e power ax cos bx dx formula. See here instead of a you have minus in, instead of b you have a. So in this formula, wherever you have a, you just go for minus in, minus in, right? Minus in, minus in. Wherever you have b, write it as a, a. That's it. Apply upper limit minus lower limit, children. Here a square plus b square, it is minus in the whole square. I square n square. I square is minus 1. So we can rewrite it as a square minus n square. You are applying upper limit. Wherever it is x, you are applying pi. Then minus, wherever it is x, you are applying minus pi. Here, if you apply minus pi, minus of minus, it will be plus. Okay, here no problem. Minus cos of minus theta is cos theta. It will be cos a pi as such. But here, sine of minus theta is minus sine theta. So this for the lower limit, sine of minus pi will a pi will become minus, will come here, right? Before it will come. Now, what you have to do is again e power I theta, e power minus I theta. Okay, e power I theta is what is a e power I theta is cos theta plus I sin theta. E power minus I theta is cos theta minus I sin theta. Theta is n pi here. You are rewriting it. Sin n pi is 0. Cos n pi is minus 1 whole power n. You are substituting it. Then you take minus 1 whole power n commonly outside. Right? Then you just take this negative inside. Then rewrite the terms. This term, first and third term will be getting cancelled. These two are the same. You will be adding together twice 2a sin a pi. Simplify it. You'll get Cn value. You just aramse substitute in the f of x. What is my first equation? For Cn value, you'll be getting your complex form of the Fourier series for cos ax in the interval minus pi to plus pi. With this, we finish our complex form of the Fourier series, children. Harmonic analysis, right? When data are given, right? The table is given numerically. With this, we'll be finding the Fourier series for this function, right? Numerical value, we'll be finding the Fourier series. Suppose this is a Fourier series for the interval 0 comma 2l, right? Then you can split it and write it as a naught by 2 plus, when n equal to 1, you put the bracket together, write a1 b1 into the respective sine cos function. When n equal to 2, write this. When n equal to 3, you write this, right? This term is said to be zeroth or harmonic or constant term. This is said to be first or fundamental. See, first or fundamental harmonic. This is said to be second harmonic. This is said to be third harmonic. If they ask only the zeroth harmonic or constant term, you have to find only a naught by 2. Up to first harmonic, you have to find this plus this bracket. If they are asking up to second harmonic till this, a2 cos 2 pi x by L plus b2 sin 2 pi x by L, you have to find. If they ask up to third harmonic, you have to find all these brackets and write the values of a0, a1, a2, a3, b1, b2, b3. What is a naught is twice mean value of f of x in the interval 0 comma 2l, right? Then an is twice mean value of f of x cos n pi x by L in 0 comma 2l. Bn is twice mean value of f of x into sine n pi x by L in the interval 0 comma 2l. Now in the table, the first and the last value will be the same. You have to omit any one value, either the first one or the last one. It is your wish, children, right? Now, first question. Analyze harmonically the data given below and express y in Fourier series up to third harmonic, right? So first, how many, first and last values are the same, y values are the same. We have to omit any one. Let us omit the last one, right? Then how many, what is it, things are there, y values are there? 1, 2, 3, 4, 5, 6. So we are taking only 6 values. So n is 6. What is the length of the interval, 0 comma 2 pi? So L will be pi. That is 2 pi minus 0 divided by 2. It is pi. Then up to third harmonic you have to write, right? So in 0 comma 2 pi, what is your Fourier series is? This only is your Fourier series, isn't it? In this, write a naught by 2, put n equal to 1, write the first bracket. it is up to first harmonic. Put n equal to 2, second, write the second bracket, put n equal to 3 here, you will be getting the third harmonic, right? Then n equal to 6, right? 6 values we are going to take. Mean value of y, a naught is into 2. So what it will be, twice mean. How to find? Summation y divided by number of terms in the y value. Similarly, a1 will be what is m? Here a1 is, put n equal to 1, cos pi x by l. Y, f of x is y actually, y into cos pi x by l. If l is pi, cos nx. Likewise, goes on. So n is 1 means cos x, n is 2 means cos 2x, n is 3 means cos 3x. Likewise, it goes on. Now, children, first in your calculator, it will be always in the degree mode. So the values, x values given here are 0, pi by 3, all are in radians. First write x value, then y value. What I want you to do is just make it in degrees. 0 degree, pi by 3 is 60 degree, 2 pi by 3 is 120 degree. So it will be easy for you to calculate the values using your calculator in degree mode itself, right? So you can easily find cos of, this is 0, cos of x is 60 degree, cos 60 degree, sin 60 degree, cos 120 degree, sin 120 degree, cos, here it will be 2x, so 120 degree, cos of 240 degree. Likewise, this x values, isn't it, substituted here. The 60 will be substituted everywhere. Here 60 means cos 60, sin 60, cos 2 into 60, 120, sin 2 into 60, sin 120. Then cos 3x, 3 into 60, cos 180, sin 3 into 60, sin 180. Likewise, you will be finding it out. Okay, you will be finding it out all the value, cos, sin, cos 2x, sin 2x, cos 3x, sin 3x, all the values you will be finding it out. You just add all this y values. It is summation y, right? Your a naught is twice summation y by n. N is 6. So you will be getting your a naught value. What is your a1 is twice summation y cos x divided by n. Y cos x means you have to multiply y into cos x value. 1 into 1, 1.4 into 0.5, 1.9 into minus 0.5, 1.7 into minus 1, 1.5 into minus 0.5, 1.2 into 0.5. You will be substituting the values, you will be getting like this. But I'll suggest a simple thing here. If you want to find b1, twice summation y sin x by n, 2 by 6 will be there. Y sin x, if you want to find y into sin x, isn't it? Y into sin x, y into sin x, y into sin x. See here, 0, other than that, it is 0.866. Plus minus, it is varying, that is different. So 0 into 0, 0 into 0 is 0. Consider 0.866 into, within bracket, take 1.4 plus 1.9 minus 1.5 minus 1.2. That's it. You'll get the value. Okay. If you are feasible with that, you can do it. Or otherwise, you can even find another column, y cos x, y sin x, y cos 2x, y sin. Likewise, also you can do it. Is your wish, up to you. Now, next we are going to find y cos 2x, summation y cos 2x into 2 by n, that is 2 by 6 will be a2, that is 1 into this into this. What I prefer is 1 2 times it comes. So 1 into here, within bracket, 1 plus 1.7. Other than that, it is minus 0.5. Minus 0.5 into 1.4 plus 1.9 plus 1.5 plus 1.2. Likewise, a3 will be, if you want to find a3, you have to multiply this into this. Okay, b2, if you want to find, see here, two zeros, other than that 0.86. So 0.86 into, within bracket, 1.4 minus 1.9 plus 1.5 minus 1.2. For y cos 3x, it will be 1 into, all are 1. So 1 into 1.0 minus 1.4, 1.9 minus 1.7 plus 1.5 minus 1.2. If you write, you'll be getting the answer for y, summation y cos 3x, right, into 2 by 6. If you evaluate, you'll be getting a3 value. Your b3 is, all are 0. So summation y sin 3x is 0 into 2 by 6. Again, it is anything 0 into anything is 0. You are substituting here a naught by 2. It is 2.9 divided by 2. It is 1.45. And then a1, b1, a2, b2, a3, b3 is 0. Likewise, up to third harmonic, we have found out, children. Now, second question. Find the Fourier series as a second harmonic to represent the function. X value varies from 0 to 5, 0, 1, 2, 3, 4, 5, and Y corresponding values are given. Children, the first and last value should be the same. Here it should be 6 and here it should be 9. They themselves have omitted. So the interval is 0, 6. So your L value is upper limit minus lower limit divided by 2. It is 3. Then they themselves have omitted one value. So remaining how many values? 1, 2, 3, 4, 5, 6. So n equal to 6. So when here it is from 0 to 6, L is 3. Your Fourier series will be like this. A naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by 3. L is 3, isn't it? Plus bn sin n pi x by, again L is 3. In this put n equal to 1. You write here a naught by 2 plus, right? Of course, plus. Again put n equal to 2. You write this. It is up to second harmonic, children, plus so on. So now what you can do is you write x values, right? You write y values. Now cos pi x by 3, sin pi x by 3 you need. Write it. Cos 2 pi x by 3, sin 2 pi x by 3. You write it. Now pi by 3 is 60 degree. Okay. Again 2 pi by 3 is 120 degrees. So 60 degree into x. Here 120 degree into x. What you can do is in degree mode your calculator will be. So even x is 0, cos 0, 1. Sin 0, 0. Likewise it goes on. Then when x is 1, it is 60 degree. So cos 60 you will be writing it. Sin 60 you will be writing it. Cos 120 you will be writing it. Right? Sin 120 you will be writing it. Then when x is 2, this will become 120. Cos 120, sin 60 into 2 is 120. Here cos 240, sin 240. Easily you can, what to say, click and then you can write all the values. Children, last case I told you, if you want to find summation, okay, summation y by n, it is normal. If you want to find a1, y into this, isn't it? What you can do is two 1 values, 1 into 9 minus 28 plus 0.5 into within bracket 18 minus 0.5 minus 26 plus 20. Also you can do, right? Otherwise, as you people do, multiply each and every term, right? Right here. Again, y into sin pi x by 3. This, 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 this. Multiply, write it. Similarly, y cos 2 pi x by 3. Y into this column. Multiply corresponding values. Write it. Similarly, y into sin 2 pi x by 3. 0 into 9, 18 into 0.866. Likewise, you multiply, write it, add it. This is summation y cos pi x by 3. This value. This is summation y sin pi x by 3. So, substitute in a0, a1, b1, a2, b2 value, the summation values here. Find a0, a1, a2, b1, b2 values. Then all these values should be substituted in equation 1 to get the required Fourier series up to second harmonic, children. Now, the table is given. The following table is given. The following table gives the variations of a periodic function. It should be. It should be a periodic function over a period t. So over a period t means the interval is 0 comma t, right? If the interval is 0 comma t, then see here the small l is upper limit minus lower limit by 2. So t by 2 it is. First and last values are the same. You are going to omit the last value. So how many values are there? 1, 2, 3, 4, 5, 6. So capital N is 6. They have asked up to first harmonic. What you have to do is your Fourier series will be f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n by x by L. What is L is? T by 2. Right? If you write this t by 2, this 2 will go to the numerator. It will become 2 pi x by t. Similarly, here also. Up to first harmonic, so a naught by 2 you are writing. Then put n equal to 1. You write the term here. Then this 2 is going to the numerator. Till first harmonic it is there. Right? Then x values you are writing. But we doesn't know what is t value is. So we cannot find a naught a1 B1 value. So you're going for some transformation. You're putting theta equal to 2 pi x by t such that put x equal to 0. X ranges from 0 to t, isn't it? Put x equal to 0, theta is 0. Put x equal to t, tt will be getting cancelled, it will be 2 pi. So it should range from 0 to 2 pi. Likewise, we have to take the transformation, children. Now x values we are writing. Put x equal to t in theta. You will be theta is 2 pi x by t. Theta will be you'll be getting in radian. As I told you, equivalent degree you write it 0 degree, 60 degree, 120, 180 degree, 240 degree, 300 degree. You write it. You need only what is ma? Cos 2 pi x by t value. So cos 2 pi x by t means what is cos 2 pi x by t is theta value. Similarly, sin 2 pi x by t is sin theta value. So you are first writing this. So cos theta means cos of 0 degree 1, sine of 0 degree 0, then cos of 60 degree, sine of 60 degree, cos of 120 degree, sine of 120 degree. Likewise, you are writing it. You are filling this two columns. Then y into cos 2 pi x by t. Y into y value is this. This into this. This into this. This into this. This into this. This. You are writing it, adding it. Again, y into this. This column with this column. You are multiplying and then you are writing here, summing it up. So what you'll get is a naught is twice summation y by n. N is 6. Summation y is 4.5. You'll be getting a naught value as such. A1 is twice summation y cos 2 pi x by t divided by n. So twice it is 1.12 summation y cos 2 pi x by t is. You are substituting it divided by 6. The value is 0.373. Similarly, b1 into equal to 2 into summation y sin 2 pi x by t divided by n. Right, you are substituting this value to be 3.0137. You are getting your b1 value. Substitute all a0, a1, b1 value in first equation. You will be getting the required what is Fourier series up to first harmonic. That's all, children. Even here we have so many problems, like they'll give x value to be 30 degree 0, 30, 60, 90 till 360. They'll give 0 and 360 will be having the same values. You can omit any one. You can do the problem accordingly, whether they are asking up to first harmonic, second harmonic. Why I didn't do is it will have so many rows, right? 0, 6, 30, 60, 90, 120, likewise it goes on. So this is a method. All the best, children. With this I finish Fourier series video, children.